It's July 2026, and every developer forum is asking the same question. Should you build with Claude Code and Fable 5, or with Codex and GPT 5.6 Soul? The obvious move: check the leaderboards, crown a winner, standardize on it. Smart teams do exactly that. And it's the wrong question. This video is about using Claude Code and Codex together in one repository. Who designs, who builds, who reviews, how they hand off work, and when to let them run in parallel. But leaderboards measure the wrong thing. Picture a construction firm. A master carpenter's work depends on the job site around them, the tools in the trailer, the permits on the fence, the blueprints on the table. Same carpenter, two different sites, two different buildings. In software, that job site has a name. Claude Code and Codex aren't chat windows. They're coding harnesses. Environments that decide how a model sees your repository, invokes tools, edits files, runs tests, manages permissions, and reports completion. Fable and Soul are the workers. The harness is the site. So when two agents produce different results, don't assume intelligence explains it. Maybe one harness loaded better project instructions. Maybe one started from cleaner context. Maybe one ran a test the other never discovered. Maybe one had browser access or was locked in planning mode. A meaningful comparison normalizes the site. Same commit, same brief and acceptance tests, same tools. Record the model, the effort setting, the harness version, the permissions, and the elapsed time. Then compare accepted results, not how confident the final message sounds. But this isn't a horse race. The real goal, in the source article's words, is, quote, independence of thought without chaos in the repository, end quote. Treat the two agents like two senior engineers with different instincts. Which engineer gets which job? Hold that question. We'll measure it. So here's the firm at work. On the left, the architect's table. Survey the site, interview the client, draw blueprints that get signed before ground breaks. In the center, the construction site. One builder working only from those approved blueprints. On the right, the inspector's clipboard, an independent professional hunting for violations, never the person who built the thing. In your repository, that becomes a serial pipeline. Claude Code explores the request and writes spec.md. You approve it. Codex implements the approved spec. Claude Code reviews the resulting diff without editing it. Codex makes the accepted corrections. Then a deterministic test suite and a final human review decide whether the work is done. That separates three cognitive roles: architect, builder, critic. So the agent that wrote the code never gets the only vote on its correctness. You've stopped asking one uninterrupted conversation to invent a plan, implement it, and then impartially grade its own assumptions. But why does only one agent write at a time? Because an agent runs a loop. Observe the repository, decide, act. Then observe again, and the loop repeats. Send two crews into one building, and one tears out a wall the other is still measuring. Each is acting on a reality that no longer exists. In Git terms, that collision means overwritten files, duplicated migrations, broken lock files, contradictory tests, or worst, a clean-looking diff that quietly combines two incompatible designs. One writer at a time is boring operationally, and it's excellent engineering. So, is parallel work ever worth it? It is, when you can isolate it. Give each builder their own lot. Git work trees do exactly that. Each agent gets its own checkout on its own branch, while repository history stays shared. OpenAI's Codex app even supports work trees natively, so agents work on separate copies without colliding. Parallelism pays where diversity pays. Run two competing architecture prototypes, two UI interpretations of one brief, alternative database migrations, an implementation racing an independent test suite, a minimal patch lane against a clean refactor lane. Same commit, same brief, same time budget. Then judge both blind. But don't split the work, as Claude takes the front end, Codex takes the basic. That boundary is crowded with shared contracts, request schemas, error states, authentication, data types, generated clients, feature flags. The rule that survives contact? Parallelize decisions or independent components. Serialize shared state. So how did two harnesses keep telling the same story? Not a giant master prompt. At the center of this firm sits the repository, the shared memory everything orbits. Around it circle 5 small versioned files: agents.md, the shared rules; spec.md, the approved behavior; plan.md, the implementation sequence; acceptance.md, observable pass-fail conditions; and decisions.md, choices and rejected alternatives. There's a 6th file because Claude Code reads claude.md, not agents.md directly. Anthropic's fix is a one-line import. Claude.md starts with @agents.md, then adds Claude-specific guidance below. Never copy rules into both files. Duplicated guidance drifts. 6 weeks later, one file says PNPM test, the other says NPM test, and the model follows whichever feels more salient. But there's a subtler trap. Let one agent write a function and its tests in a single stream, and it can encode the same misunderstanding twice. A perfectly passing mistake. That's the builder inspecting their own building. The fix: hand the second harness only the specification and have it write tests designed to fail plausible wrong implementations, blind to the code until its first suite is complete. Here, though, the construction analogy breaks. Human architects and inspectors share training, share memory, and can phone each other to clarify. An agent handoff transfers nothing implicit, no hidden reasoning, no tool state, no conversational assumptions. Continue what Claude was doing hands the next harness an empty envelope. Therefore, every handoff travels as a compact packet with 6 sections. Objective: what must change and why? Current state: commit, branch, modified files. Decisions: approved architecture and rejected alternatives. Constraints: scope and compatibility boundaries. Acceptance: commands and user flows that must pass. Open questions: what to resolve rather than guess. 2 disciplines make the packet work. Reference files instead of pasting them. The repository is already shared external memory, so don't burn context reproducing code the agent can read itself. And the receiver must verify the packet against the actual repository before editing, because a stale plan.md is not authority over real code. Now, which agent takes which role? Vendor evidence suggests starting positions. Anthropic reports Fable 5 is especially strong at prototyping, long-running work, and broad code-base reasoning. OpenAI reports Sol leads the coding agent index at 80, with records on Terminal Bench 2.1, terminal operations, validation, long horizon execution. So, try Fable for product interpretation and prototypes. Try Sol for terminal-heavy implementation and polished delivery. But label that honestly. It's a workload routing hypothesis, not a benchmark verdict. Audition it. For 10 representative tasks, track accepted completion rate, human interventions, reverted changes, cost, and time to an accepted result. You might find Fable is your better builder and Sol your better reviewer, or the reverse, or that the model matters less than whether the task began with a good acceptance test. Here's the recipe to run this week. First, write agents.md and import it into Claude.md. Second, Claude Code in Plan mode interviews you and produces spec.md. Third, edit that spec yourself. Cut speculative features. Add non-goals. Fourth, Codex implements it in a clean work tree with tests. Fifth, a fresh Claude Code session reviews the diff and reports findings. It doesn't rewrite. Finally, one narrow correction pass, then full deterministic checks. So, back to that July 2026 question. Claude Code or Codex? You never had to fire either professional. The new skill isn't writing the perfect prompt to the perfect model. It's running a small engineering firm whose members happen to be coding agents. They don't have to agree. Their disagreement is the point. The repository, the tests, and you decide which argument survives.